Dear students, I am Dr. Tamrakar from Bharati College of Engineering and Technology. I am teaching food machinery in B 5th semester. Today we will do our next class. Today we will discuss next problem. A jet of water having a velocity of 30 meters per second strike a series of radial curved band mounted on a wheel which is rotating at 200 rpm. The jet make an angle of 20 degree with the tangent to the wheel at the inlet and leaves the wheel with a velocity of 5 meters per second at an angle of 130 degree to the tangent to the wheel at outlet. Water is flowing from outward in radial direction. The outer and inner radii of the wheel are 0.5 meter and 0.25 meter respectively. Determine wave angle at inlet and outlet and work done per unit weight of water, and third, efficiency of the wheel. Here, this is the outlet angle, this is a curved vane, and this is inlet angle, this is U1 at angle alpha, V1, this is VW1, point C, this is theta, VF1, and here in the outlet angle, this is VF2, this is angle beta, V2, and angle phi, VR2, this is U2 and VW2. The inner radius is R2 and outer radius is R1. Here, this is the tangent line at point B, and here this is the tangent line at point E. Okay, now we will start solving this question as the data given here. Velocity of jet V1 is given 30 meter per second. 30 meter per second. Speed of wheel is given. Speed of wheel n equal to 200 rpm. It has been given. So the angular speed omega, this omega equal to 2 pi n by 60. By putting the value of n here, this 2 into pi into 200 by 60. So the value of omega here 20.94 radian per second. Angle of jet at inlet, angle of jet at inlet, the alpha is given 20 degree, and velocity of jet at outlet, velocity of jet at outlet is V2 equal to 5 meter per second. It has been given, and angle made by jet at outlet angle made by. Now, angle made by the jet head outlet, the jet head outlet with the tangent of field with the tangent of wheel to that is 130 degree. This is 130 degree given. So we have to find out angle beta. This angle beta is equal to 180 minus 130 equal to, this is beta is 50 degree. Outer radius R1 is given 0.5 meter and inner radius R2 is given 0.25 meter and velocity u1 equal to omega r1, that is 20.94 into 0.5. So this value of u1 is 10.47 meter per second and u2 equal to omega r2, that is 20.94 into 0.25. So this is, the value comes 5.235 meter per second. Now we have to calculate when angles at inlet and outlet made by relative velocity VR1 and VR2, that is angle theta and phi. Here from triangle A, B and D, in this triangle, bigger triangle ABD, VW1 is equal to V1 cos alpha. This is VW1, this can be replaced by V1 and this is alpha, so V1 cos alpha, and VF1, putting the values here, V1 cos alpha, this V1 is 30 and cos 20, so this value VW1 comes 28.19 meter per second, and the value of VR1, this value of VF1, this one is VF1, this value is VF1, this is V1 sin alpha, putting the values here, 30 sin 20, so this comes 10.26 meter per second. Now in the triangle CBD, in triangle CBD, tan tan theta. Here tan theta equal to VF1 by CD, and the value of this CD is VW1 minus U1. So this is VF1 by VW1 minus U1. Putting the values here, this is 10.26 divided by 28.19 minus 10.47, the value of U1. So this comes 0.579. So here the value of theta comes 30.07. This is the value of theta, or it can also be written as 30 minute and 4.2 second. This is 30 minute and 4.2 second. From the outlet velocity triangle, EFG, here the value of VW2, this value we have to find out, that is V2 cos beta. This is beta, so this is VW2 equal to V2 cos beta. Putting the values here, the value of V2 is 5 cos 50. So this comes 3.214 meter per second, and the value of VF2 equal to V2 sin beta equal to 5 sin 50. So this value comes 3.83 meter per second. Now in triangle EFG tan phi, here this tan phi is equal to VF2 by U2 plus VW2. This is equal to VF2 by U2 plus VW2. Putting the values here, this is 3.83, this divided by 5.235 plus 3.214. So this comes 0.453, or this is equal to the value of phi here comes 24.385 degree, or it can be written as 24 degree and 23.1 minute. This is the value of phi. Now we have to calculate the work done per second by water is given by rho A V1 VW1 U1 plus VW2 U2. Here positive sign is taken because beta is acute angle here. So the work done per second per unit meter of water striking per second is the work done per second by unit weight of water stacking per second is equal to rho A V1 V W1 U1 plus V W2 U2 is divided by weight of water per second is rho A V1 into G. By putting the values here, work done by cancelling the rho AV equal to 1 by G V W1 U1 plus V W2 U2 Newton meter per Newton. Putting the values here, 1 by 9.81 into 28.19 into 10.47 plus 3.214 into 5.235 here this value comes 31.8 Newton meter per Newton weight of water. Now with unit weight of water stacking per second. Third, we have to calculate the efficiency. The equation is 2 V W1 U1 plus V W2 U2 is divided by V1 square. Now putting the values, theta equal to 2 into 28.19 into 10.47 plus 3.214 into 5.235, this whole divided by 30 square. So here the value is 0.6932 or this is 69.32% efficiency comes of this machine. And you have to do similar numericals from the university paper for getting the expertise. It is very important to solve number of numericals on this topic. This topic is very important. Thank you.